So good morning to one and all. Here your course name is System Design and Control. In the module 1 we are going to discuss about the systems and their representations. So what is the basic concept of involved in a control system? So as you know very well, control engineering is concerned with the techniques that are used to solve the 6 problems in an efficient way. The first is identifications of problem, that is to measure the variables and convert data for analysis. The second one is the representation of problem, to describe a system by an analytical form or mathematical model. The solution problem, to determine the above system model response. Next one, the stability problem, general qualitative analysis of the system. Next one, design problem, modification of an existing system or develop a new one. Optimization problem, form a variety of design to choose the best. So what is the terminology used in a control system? A system is nothing but a combinations or arrangement of different physical components to form a whole unit such that combining units perform achieve a certain goal. Control, the action to command, direct or regulate a system. Plant or process, the part of a component of a system that is required to be controlled. Input, it is a signal or excitation supplied to a control system. The output, it is the actual response obtained from the control system. Next, controller, the part or a component of a system that controls the plant or disturbance. So the signal that has an adverse effect on the performance of a control system. Control system, a system that can command, direct or regulate itself or another system to achieve a certain goal. Automation, the control of a process by automatic means. Control system, the interconnection of components forming a system configuration that will provide a desired response. Actuator, it is the device that causes a process to provide the output. It is the device that motivate the power to the process. So design, so the process of conveniencing or inventing the forms, parts or the details of a system to achieve a specified purpose. Simulation, a model of a system that is used to investigate the behavior of the system by utilizing actual signals. Optimization, the adjustment of the parameters to achieve the most of the favorable advantages. Designs, feedback signal, it is nothing but a feedback, that is the output of a system that can be given as an input. Negative feedback, the output signal is feedback, so that it is subtract from the input signal. Block diagram, that is a representation of the concept of the system. So next is signal flow graph, a diagram that consists of nodes connected by several directed branches, that is a graphical representation of a set of linear relations. Specifications, statements that explicitly state what the device or product is to do. It is defined as a set of pre-described performance criteria. Open loop control system, a system that utilizes a device to control the process without using feedback. Thus, the output has no effect upon signal to the processor. A closed loop feedback control system, a system that uses a measurement of the output and compares it with the desired output. The regulator, the control system where the desired values of the controlled outputs are more or less fixed and remain. The problems is to reject disturbance effect. Servo system, the control system where the outputs are mechanically quantities like acceleration, velocity or position. Stability, it is that describes whether the system will be able to follow the input command. In non-rigorous senses, a system is able to unstable if its output is out of control or increases without one. Multivariable control system, a system with more than one input variable or more than one output variable. Trade-off, the result of making judgment about how comparisons must be made between conflicting area. Open loop control system and closed loop control system. So it is a open loop control system. It is a control system where control action only depends upon the input signal alone and it does not depend upon the output. Closed loop control system, it depends upon input signal and as well as output response. So here the open loop control systems that can be depicted here, whereas input is nothing but R of t given as control, and your control signal is U of t, and that can be given as an input to your plant, and whereas output is C of t. So what are the examples of your open loop control system? Traffic signal, washing machine, and the toaster, etc. These are all the examples of your open loop control system. Next we discuss about what are the merits of open loop control system. Here, the first one is a simple design and easy to construct, economical, easy for maintenance, highly stable operations. And disadvantages: non-accurate, reliable when the input or system parameters are variable in nature. Recalibration of the parameters are required from time to time. Next, a closed loop control system. In a closed loop control system, it is a control system where control action depends upon both of its input signal and output response, and it is shown in figure. This is the block diagram representation for a closed loop control system, where a reference input is nothing but R of t, and again a feedback which is given to the error detector. Again, both are it takes process inside the error detector, and again, it is given as an input to a controller, followed by open loop system, and again it is given as an output, that is C of t. So what are the examples of a closed loop control system? That is automatic electric iron, then missile launcher, speed control of a DC motor, etc. These are all the best examples for a closed loop control systems. The next merits of closed loop control system. First one is more accurate operation than that of open loop control system. Second point, can operate efficiently when the input or system parameters are variable in nature. Less nonlinearity effect of these systems on output response, a high bandwidth of operations. There is no facility of automation. There is a facility of automation, and your last merit is time to time recalibration of the parameters are not required. So what are the demerits of your closed loop control system? The first is complex design and difficult to construct, expensive than that of the open loop control system, complicated for maintenance, and a less stable operation than that of open loop control system. So what are the differences between your open loop control system and closed loop control system? In the open loop control system, no feedback is given to the control system, whereas in case of a closed loop control system, a feedback is given to the control system. And your second point is cannot be intelligent and intelligent controlling actions. Your third point, there is no possibility of undesirable system oscillations, whereas in case of your closed loop control system, introduces the possibilities of undesirable system oscillations. The output will not vary for constant input, and provide system parameters that remain unaltered, whereas in case of your closed loop control system, the output may vary for a constant input depending upon the feedback. Next, the system output variations due to variations in the parameter of the system is greater, and the output vary in an uncontrolled way. Whereas in case of a closed loop control system, system output variations due to variation in its parameters of the system is less. So in addition to that, your open loop control system is more stable because of the absence of your feedback, and whereas in case of a closed loop control systems, you have a feedback path, therefore the system is less stable or prone to instability. And in addition to that, your open loop control system, in case of your open loop control system, system is very sensitive in nature, whereas under closed loop control system is less sensitive to disturbances. So moreover, in case of your open loop control system, since we have a plant and a controller, the feedback path is absent, therefore it is very simple to design. Whereas closed loop control system consists of a feedback path element, then controller, error detector, plant. Therefore, it seems to be that your system seems to be a complex one. So these are all the major differences between your open loop and closed loop control systems.